our software is continuously monitoring the resource requirements of the application, so what memory requirements they have, what processing requirements they have, and we're applying underlying algorithms and predictive queuing theories to best fit work to the resources in the system. And so when we see that a system is becoming more heavily loaded and is going to run into a resource contention problem, we will take proactive steps to resolve that contention. So we have a number of mechanisms that we've developed that bring a lot more order into the way jobs get through the system. This is why people are traditionally now keeping their multi-core systems at an artificially low utilization rate because they're afraid of the possible negative outcomes when resources are exhausted. We allow them to put more work on the system safely, and if a contention develops, if some problem develops that needs to be resolved, we do this automatically within the system and ensure that they get the best possible result. So our product suite is the micro-virtualization, which is really a new style of virtualization. In the kernel, it controls access to cores and memory. And under the micro-virtualization umbrella, we have 3 different products that look at how do we report on resources that are used by these jobs, which is Job Profiler. We have our MCOP multi-core manager, which guarantees the order and control of resources for the applications. And the last piece is a notion of dynamic project containers that allow you to set policies that ensure that users get a certain level of committed resource, both for cores and memory.
Okay, welcome to VCODYNE. So we are HPC cloud vendor. So the good thing is that we are providing infrastructure on demand, HPC infrastructure on demand. And we are European based with European experts. So this is giving you the spirit of our company. So nothing about US Patriot Act, a very cautiousness about data management and regulations, about how your data are deleted, how your data are controlled and managed across the board. So everything is made and architecture in order to fulfill EU regulations. So that's one good thing. The second good thing is that you are able to resize your cluster based on physical nodes, HPC infrastructure based. All is dedicated to you, so we are providing the keys of your car and you're in full control. So that's a very important thing. And then you're able to resize your cluster according to the workload. So we have developed our own technology to be able to integrate the workload. So that means as soon as you're throwing jobs, the cluster is able to understand that he needs to ramp up, and after the job is done, to shrink again to the minimum size. And this is very dynamic in terms of minutes. You can have a big number of nodes and then shrink again to the minimum size. Okay, so one more thing about VCODYNE is that we are an SME, so we are paying much attention to SMEs, whether they are dealing with chemistry, EDA, mechanical, or other typical HPC segment. We have data centers in Germany and in France, and we are helping them then to fulfill their peak requirement in terms of HPC on-demand capacity, or to help them to put their application, if they are developing an application, on a SaaS model. So we are then providing the infrastructure as a service, and they are able to provide their software as a service. That's VCODYNE. We are expert in grid computing, in clusters, in HPC cloud, and we would be very pleased to welcome you. Please visit us on our website and feel free to contact us. Thank you.
First of all, big data is a relatively new computation environment in the last 2-3 years. And the reason there's a lot of concern or whatever is it's not clear yet to a lot of people what is the best way to go going forward. And there's many different solutions. You know, in 1982 when Convex started, they were saying the same thing about supercomputing. It was difficult to program. They couldn't do applications, etc., etc. And Convex produced automatic vectorizing compiler that took, at that time, standard VAX Fortran and vectorized it and parallelized it, and the world began to change very rapidly. It became easy to use. And big data is a similar thing. What is the right programming paradigm? What is the right computer architecture? And one of the things that Convey is doing is the same thing, the machine which is the simplest to program. So from our perspective, the reason I don't consider it a big deal is we're bringing our compiler technology to make it easy to use. We're creating machine architectures which let you directly address terabytes and ultimately exabytes of data. And we're letting you program in standard C, C++ with some extensions that make it relatively straightforward. From my perspective, and the reason the name of my presentation was Big Data So What is, I've been doing this all my life. Here's a new application, I'll figure it out. And I'm with a company that we are figuring out, and we'll deliver a solution. And I know it sounds overly easy, but shortly we will have some announcements which I believe people will go, whoa, we don't know if this is the right way, but it's a very interesting way. If I'm doing like seismic processing, my data set, once I start, is fixed. I may try different algorithms to see whether there's a hydrocarbon, but my data set, once I get that sample, is generally fixed. In big data, it's changing in real time. Like if I'm Google or Facebook, the data set I have now, the only thing you can say for sure is in 5 minutes that data set will be different because people are logging in, I'm doing new searches. And I think because of the fact that data is being added all the time in real time, that's a very different model from the people who normally come to like ISC. We actually began working on this 2-3 years ago. And the reason is some of our best customers were telling us that they saw this coming. They were innovators in their own market space, and they felt that we had the opportunity, we Convey, an architecture that could be more adaptable to where they're going than the rest of the market. Again, big data also means you want bigger memory, bigger disk systems. The data is generally unstructured. Like I said, there's no X, Y, Z. As a young company, we have to be agile and move where the market is going and where we can be first and not third. And because of our background from Convex, where someone says I need a terabyte of memory or more, to us it's okay, so what? You want it? Here's what it costs, when you want it delivered, which is the normal HPC mentality, at the high end. So we use that mentality, and because we're reconfigurable, where rather than having instructions to do 3D matrices, we can do instructions to do threading. So 26, but we had our performance in terms of edges per second, 7.76, was one of the best for this size, so we didn't have enough physical memory, which will be corrected shortly. So, and the way we got to this point is creating an instruction set that was specific to multi-threading, which is one of the ways people program for big data. I know this is very difficult to, when you're a startup, we can put together a meeting in a half an hour to make decisions in weeks and execute a lot faster. That's one of the benefits of a startup. I'm not saying big companies can't do it, but when I was in a big company, I'm lucky if I can have a meeting with that people in 1 month. That would take 6 months then to make a decision. And because we're small, we have to focus on niches that we can do well at, not broad based. I don't want to be number 5 into the market. I want to determine the market, and that's where Convey is going. Or come visit our website at conveycomputer.com, and you'll see product briefs, some customers, And of course, we'll be at ISC'12 in Salt Lake City, and we'll have a major presence there. So if you can't make it to Hamburg and you want to see some interesting announcements, we'd like to see everyone at Salt Lake City in November. Thank you very much.